Okay, for what we have concerning parametric representations of solution sets. Now, parametric representations will involve, the letter T. And let's say that if you're looking for a parametric representation of an equation, and we'll say we have something like x plus 3y is equal to 5. Okay, and for the last letter, you're going to put this in terms of t, and for the prior variables, we're also going to put in terms of t after we designate, let's say, t for the variable y. Okay, so right now we got x plus 3y is equal to 5. And if I rewrite the equation in terms of the leading variable, okay, in this case x, so we're not dealing with anything like the slope-intercept form of a linear equation. We're going to write the equation in terms of the first variable. Okay, so we have in the case of the rewrite, okay, so you will have the x is equal to 5 minus 3y. Okay, and again, for the last letter that appears, we have to be y. So we have that y is equal to t. And going back to what I have for x, now I said that x is equal to 5 minus 3y. And looking at putting t in place of y, it's going to follow that for what we have in the case of x, upon putting y in terms of the parametric layout, we're going to have the x is equal to 5 minus 3t. So we have, in the case of the solution set, okay, we're going to have the x is equal to 5 minus 3t. And that y is equal to t. And let's say that if I have something like, let's say that we have y of 1 plus 2y of 2 minus 5 y of 3 is equal to 7. So I'm going to write this equation in terms of the leading term, in this case, which is going to be y with the subscript value of 1. So if I write this equation in terms of y of 1, so I'm just going to move the 2y of 2 and the 5y of 3 and rewriting. Okay, so we have 7 minus 2y of 2 plus 5 y of 3. And for what we're going to have here, okay, for the variable that appears last, either has the highest value subscript or comes last in terms of alphabetical order, we're going to assign the variable t. Okay, so we have, so we're going to have that y of 3 is equal to t. And sort of doing a little bit of backpedaling, I'm going to add yet another variable. Okay, so y of 3 is t, and for y of 2, just as 2 comes immediately before 3, like in the case of Arabic numerals, well, we have in the English alphabet, the letter S comes right before t. Okay, so we'll say that y of 2 is equal to S. So for what we have, putting in parametric terms, for y of 1, okay, so again we had that y of 1 is equal to 7 minus 2 times y of 2 plus 5 times y of 3. And again, just plugging in. Okay, so we got S in place of y of 2. And again, we have t in place of y of 3. So for what we're going to have in the case of y of 1, okay, so this will come out to 7 minus 2s plus 5t. So we have, in the case of the parametric solution set, we have y of 1 is equal to 7 minus 2s plus 5t. We have y of 2 is equal to s, and we have that y of 3 is equal to t. Again, this is going to be the parametric solution set. Okay, moving along. Okay, and you might have some systems that will be parametric, but you also might have the solutions throughout to consist of constants. And we'll have in the realm of using back substitution to solve the system. We'll say we have for the first, we'll say we have a system of equations, okay, and we'll say that we have 2x of 1 Okay, so we'll say that we have for the first system, we'll say that we have 2x plus 4y is equal to 8, and we will say in advance, okay, that we have that y is equal to 2. Okay, so you have y is equal to 2, and we're looking at the same y, whereupon we're going to have 2x plus 4y is equal to 8. Okay, so we have for this system, okay, so you have 2x plus 4y is equal to 8. And again, we had that already given that y is equal to 2. And here we have 2x plus 4 times 2 is equal to 8. And we have that 2x plus 8 is equal to 8. And if you subtract 8 from the left hand side, again, we have that 2x is equal to 0. And we have with division by 2, okay, it turns out that x is equal to 0. So for this particular system, okay, we're going to have that x is equal to 0. And again, y we have given at 2. Okay, now let's say we have, like in the case of another system, and we'll say that we have something along the lines, and we'll say that we have x of 1 plus 3x of 2 minus 4x of 3 is equal to 5. And we'll say that we have also in the mix, okay, we'll say that we have x of 2 plus x of 3 is equal to 7. Okay, so for what we have in the case of the second system, now there are various pathways we can go about solving. And we'll put the first equation, say, in terms of x of 1, and say that is equal to 5 minus 3 times x of 2 plus 4 times x of 3. And say what? And if I put the second equation in terms of x of 2, then we have x of 2 is going to be equal to 7 minus x of 3. Alright, so I express this equation from the top in terms of x of 1, second equation in terms of x of 2, and there are no additional equations where I can write the equation in terms of x of 3 apart from manipulating x of 1 and x of 2. So in terms of the last variable, okay, you can say that x of 3 is what is regarded as a free variable. And this is a little bit of a buzz term that we will be using once we cross over to matrices. And for what we have in the case of x of 3, say whatever we have for a free variable, we'll say that x of 3 is equal to t. And looking at back substituting, we have that x of 2 is equal to 7 minus x of 3, which is going to be equal to 7 minus t. And we have in turn for x of 1, again have 5 minus 3 times x of 2 plus 4x of 3. And I think I'm just going to move down here. So you got x of 1 is equal to 5 minus 3. And we have with x of 2, again you have times the quantity of 7 minus t. And 4 times x of 3 is going to be 4 times t. So you have for x of 1, and just looking at the constants, so you got 5 minus 3 times 7. Negative 3 times 7 is negative 21. 5 minus 21 is going to be a negative 16. Negative 3 times negative t is positive 3t, added to 4t, so we have negative 16 plus 7t. And so we have for this particular set, okay, where we have in parametric terms, we have x of 1 is equal to negative 16 plus 7t. We have x of 2 again is equal to 7 minus t. And again we have x of 3 is equal to t. And just adopting one of our textbook problems. Okay, so we have x of 1, x of 2, x of 3 all over again. So we have x of 1 plus x of 2 plus x of 3 is equal to 0. And we have given that x of 2 is equal to 0. Okay, so if I were to substitute, okay, so you have with x of 1 plus x of 2 plus x of 3 equal to 0. Okay, again, so x of 2 is equal to 0. So this equation at the top is just going to be x of 1 plus x of 3 is equal to 0. And guess what? We're going to have that x of 1 is going to be equal to negative x of 3. And I cannot do any manipulation with x of 3 in terms of isolating outside of saying that x of 3 is equal to the negative of x of 1. And I'm going to assign the parametric t to the last of the variables. Okay, so if we have that x of 3 is equal to t, again, we have for x of 1 is equal to the negative of x of 3, and since x of 3 is t, x of 1 is equal to negative t, and so just taking what we have, again, consolidating, we have that x of 1 is equal to negative t, and we have given x of 2 is equal to 0, and we have that x of 3 is equal to t.